Hello and welcome back to Mr. Powers Teaches. What are we doing again? Algebra. We're doing word problems. Lots of different word problems just so we can see them worked out. All right. First things first. Let's do some more word problems. This time we're going to do a pricing problem and we're going to do a mark up or mark down problem. That's not what I meant to write. Distance rate problem. So pricing could be a markup or a mark down. But the distance rate problem, I think we'll try to squeeze one of those in this as well. Maybe, maybe not. We'll see how it goes. Okay. A calculator has been marked up 15% and is being sold for $78.50. How much did the store pay the manufacturer for the calculator? Okay. So my mind goes a blank. I read these, and it is important to understand these. Usually, very much so, to a point. You don't have to have a really deep understanding, but it does help. So let's just start with this. Calculator's marked up 15%. Okay. So we have that cost, right? So I'll say C. Let's say C. We have the cost of the calculator, and it's been marked up 15%. So that means that we add to that cost 15% of the cost. So that's 0.15 times C. Okay. So we did that. We have C plus 0.15 times C. See, I'll try to write straight here. I forgot how to write straight. Anyway, and is being sold for $78.50. Okay, great. So we have the cost plus 15% of the cost equals the amount we're selling it for. That makes sense. And that's going to be $78.50. So there, I got my equation. Because I guess I did need to know what's percent, marked up a percent. That means I'm adding 15% of the cost. How much did the store pay the manufacturer? So in other words, what's C? That is going to be C, our cost. The cost for the store, right? So now we just simply solve it. C plus 1.5C, 1.15C is 1.15. Sorry, C plus 0.15C is 1.15C. There we go. And we're saying that equals 78.50. So this is a very easy, very straightforward problem, and there is really nothing to diagram in this one. All right. And so once again, this guy is nice because we just have one step. I want to get C by itself, so we're going to divide by 1.15C. Whatever you do to one side, we must do to the other, and we get that C, which I decided to call it C. The cost of my calculator is going to be about 68.26087. But it's like, what did we pay for it? Let's use a little rounding. It doesn't make sense. So we're going to say it was about 68.26, right? We'll round to the hundredths since we got pennies. We can go down to a cent. So there we go. So that would be our cost for the calculator. That's what the store paid. So those ones are very easy, very straightforward, I feel like, as long as you understand that. And that was a markup. If it was marked down, we would do the other thing. It would be minus the percent we got marked down. So now let's go ahead and do a distance rate problem. So that was so short. We can do another one of these. So let's do a distance rate problem. We're going to copy that in here. Paste it in. It's going to be so much fun, you guys. These are the best. All right. So again, let's read it. Now, these ones definitely lend themselves to some diagramming, usually. Very good. So we're going to try to diagram these as best we can. Two cars are 500 miles apart and moving directly towards each other. One car is moving at a speed of 100 miles per hour. The other is moving at 70 miles per hour. Assuming that the cars start moving at the same time, how long does it take for the two cars to meet? Okay, very good. So let's go ahead and start diagramming this out. So I got here. Oh, okay. There, look at a beautiful straight line. Okay, so we got our one car, right? We got a car A over here. He's going this way. And we have a car B over here. He's going that way. And they're going to meet somewhere. Let's say they meet right here. Okay? And so we got car A goes this distance all the way to the end. And car B, we'll say, is going this way. And so let's see what we can say about these guys. Now, I guess in this situation, what do we need? Last situation, we needed to know how to do markup, markdown, percents, that stuff. In this one, we're talking about two cars moving. We're talking about distance and time and speeds. Do we have a way to relate all those things? And yes, we do. And so this is a formula we have to keep in mind whenever we deal with these, and that is distance equals rate times time. And let me see here. Let's go ahead and I can never decide. We'll just use all lowercase. Distance equals rate times time. This is a very important thing to remember. And so we are going to use this. So first we got two cars 500 miles apart. Oh, so it'd be good to, mark that. Okay, so we're going back here. We're still working on our diagram. That's 500 miles. Moving directly towards each other. One car's moving at a speed of 100 miles per hour. Okay, so let's say car A is 100 miles per hour over here. 100 miles per hour. And that's the speed we're going, and we got this distance here. And then car B is going what? It's going 70 miles per hour. So car B is 70 miles per hour. Okay. Now, so far it's not going to work for me because I got a speed here and I got distance here. We need to be able to relate just distance to distance or speeds to speeds. We got to do something here. Assuming the cars start moving at the same time. Ooh, time's the same. How long does it take for each of the two cars to meet? So, in other words, this distance here, the distance is going to be 100 times our time. I was going to put T for time. So there's my distance equals rate times time. And this distance here, since we have 70 miles per hour, it's going to be distance, that distance. So let's say over here, this is D1. Oops. That's D1. And then over here, let's call this D sub 2. That's a different distance, right? That distance is 70 times T. Nice. And then now, because it's distance times time, or a rate times time is a distance, and we know these two distances add up to the whole thing, we can totally write an equation, which is our goal. So according to my diagram, I have D1 plus D2 equals 500. That's what I got so far. Okay? But I also know that, let's make ourselves a little bit more room here. We also know what D1 and D2 are. We figured those out. D1 is 100T. So we have 100T plus D2, our second distance, was 70T. And we know that total distance is going to be 500. Now we got an equation with one variable. We can solve it. We've done the hard part. And so this is the way I like to do these. Now we can just solve the equation. We'll be done. So 100t plus 70t is 170t equals 500. Divide both sides by 170 so we can get our variable by itself. And we shall get that t equals whatever 500 divided by 170 is, which is about 2.941176. And were we in hours? What is t? Yeah, miles per hour. So that's t. T is hours, so hours. Okay. So we did this work. We got t. Let's just make sure that's what they were asking for. Were they asking for each car's distance, or were they asking for the total time it took? What were they asking for? I never remember. So let's just go back. Assuming the cars start moving at the same time, how long does it take? All right, well, there you go. That's how long it takes, about 2.94 hours. So we are done. It took about 2.94 hours, almost 3 hours for them to meet. But if they wanted to ask, hey, how far did the first car go? The car going 100 miles per hour. How far did it go? We could figure that out now, right? Plug in that value for t, and we can say, well, it went about 294 miles, and so on and so forth. So that's how we do that. So that'll cover it for this video. I hope you found this useful, and until next time, enjoy doing math.